Hi, this is your Chapter 3 demo program. This is exercise 4 on page 70. The problem reads, Chris Johnson wants a program that calculates and displays a 10%, 15%, 20% tip on his total restaurant bill. First, create an IPO chart for the program. Then desk check the algorithm twice using 3580 and 5678 as the total bill. After desk checking the algorithm, list the input, processing, and output items in a chart similar to figure 323. And enter the appropriate C++ declaration statements. So this part is new. After the desk checking, list the input, processing, and output items in a chart similar to figure 23. We're actually going to start to write some code. We're going to be doing what's called variable declaration. So this is the beginning of a program. We're going to incorporate this into our programs later as we go along. So first, the IPO chart. Well, remember an IPO chart, you have to figure out what the output is. So go through and read this. Displays is a key word for output. So if I see displays, this is what's following is going to be my output. So this one displays a 10%, 15%, and 20% tip on the total restaurant bill. So that's my output. And I put them down here, amount for a 10% tip, the amount for a 15% tip, and the amount for a 20% tip. My output. Now the input on this isn't as clear as it is sometimes. It doesn't say the user will enter or anything like that. Sometimes your program specifications, especially if they're real and they come from a user, are going to be somewhat vague and you might have to read into it a little bit. Well, we know, we've all been to a restaurant, we know that a tip is based on the bill. But if you read this, it says calculates and displays a tip on his total bill. Well, where's that going to come from? It has to come from the user. It can't come from anything else. It's going to be different every time he runs this program. So it's not something that can be built in. It has to be input from the user. So that's going to be my input. So I put total bill down there. So the total restaurant bill is my input. Now in this chapter they also introduced variables that are neither input nor output. They're used for calculations. And in this case they're constant variables. They're variables that will not change. So the percentages for the tips, the 10%, 0.10, 15%, 0.15, 20%, 0.20, are constants. They can only ever be that. 0.10 can only be 0.10. It can never change into something else. And they don't come from the user. It's incorporated into the program. We need these for our calculations. So those are our processing variables. And they don't really show up in the program declaration statement. You have to read into that a little bit too. These are just like math word problems. So I put those down here in my processing. Now once we have our variables defined, our data, what we're going to output, what we need to get from input, and what we have that can be provided as part of the program, neither input nor output, in this case our constants. Now we can start our program where we actually do the algorithm and tell it what to do. So first thing we have to do in this program is get the user to enter the total bill. That's step number one. Until that bill is entered, we can't go on. We can't do calculations. Once the bill is entered, then we can calculate our three output items. So the amount for the 10% tip, and here it's called exactly the same thing, amount for the 10% tip, is my total bill, what was gotten in input, times this constant that I declared up here in the processing area, in one of my processing comments, percent for 10% tip. So percent for 10% tip, and when it does the math, it's going to use this 0.10 because we assigned that to it. We do the same thing with the 15% tip and the 20% tip. When we're done with the calculations, all the output has been calculated, then we can display it. So that's our final step. And remember, this is an IPO chart. Input, process, output. That's why it's called an IPO chart. Now the next thing we need to do is desk check. Don't confuse the desk checking data with the data that you might use for processing in your program. two different things. Desk checking is once you have your algorithm figured out, we try it with different values to see if it works. So down here I made another table, and they want us to desk check the bill using the algorithm using 35.80 and 56.78. So if the user enters 35.80, following our algorithm, and you can solve this with a calculator, the amount for the 10% tip will be $3.58. So the amount for the 10% tip is the total bill, $35.80 in this case, times percent for the 10% tip, which is 0.10, and that's $3.58. That's one we can do in our head. It's easy enough to see that it's correct. We follow through and use a calculator. These are the amounts we get for the 15% tip and for the 20% tip. You can use reasonability tests to determine whether or not this is correct. If, for example, your tip amount will come out to be more than the total bill, you know something is wrong. That's not correct. Or if you have a $35 bill and the tip comes out to be 5 cents or a negative number, you know that's not correct too. So look at your output first and determine whether or not it's correct. Double check it with the calculator and then you'll know for sure. When we figure out through the desk checking with the 5678, these are the amounts that we come up with using a calculator. Notice it's calculating 3 digits to the right of the decimal place. It's not rounding, even though currency would be rounded up. It's not doing that. We'll learn how to do rounding when we get to the next chapter. Okay, so now we've done the desk checking. We know our algorithm is correct. Here we're starting our translation into the C++ code itself. So these are the variables that we had: our input, processing, and output variables. These are the names we used in our IPO charts. Planning is done in English-like instructions, but that's not how we write our code. Our computer expects our code to be written a specific way, following the rules of that language. So we need to translate it from our pseudocode that we use in IPO charts into the actual C++ instructions. So what we've done over in this column is we have declared the variables as it would be written in a C++ program with the proper syntax. So in input we have a variable called total bill. In the C++ program, it has to be declared as a variable. When you declare a variable, there are 3 parts to it. It needs a data type, a name, and an initial value. So the data type for this variable is type double. A double type variable is one that has something to the right of the decimal point. It's not a whole number. So it potentially could have a value to the right of the decimal point. Total bill is the name of the variable. Remember from reading the chapter that there are rules to naming variables in C++. They cannot start with a digit or an underscore. It can contain digits, underscores, and letters. No spaces ever in a variable name in any programming languages. No programming language allows a space at all. So decided, well, I'm going to call it total bill. It should be something that makes sense. Okay, you don't want to just call your variables X or Y or Z. That's really poor form. It doesn't mean anything to somebody that's reading the program later on. If it's a total bill, we're going to call it total bill. I use a method that we call camel code because it kind of has looks like there's humps in it like in a camel. Instead of saying total underscore bill for my 2 words, I have total, and then I start the second word bill with an uppercase letter. So that way it kind of tricks your eye. It looks like 2 words even though it's not. And then the equals 0.0 is initializing this variable, clearing out its space in memory, so any data that's left over there from a previous run or another program that ran is eliminated from that space in memory. So we've declared the variable, we've given it a data type, double, we've given it a name, total bill, and then we've initialized that variable, cleared out its contents so it's ready to go. And then every C++ statement ends with a semicolon, so we have a semicolon at the end. Now these processing variables, they're slightly different. These are going to be a type double, because they do have something to the right of the decimal point. But we're starting it out with this keyword const, C-O-N-S-T, and const stands for constant. These are constant variables. Their value will not change. So we start with that const keyword. So the first one have const. It's a constant, double. It's a real number, not a whole number. It can have something to the right of the decimal point. And then I need to give it a name. I cannot use a percent sign, special character. Only special character I can use is an underscore. I cannot start with a number. So the name's a little more convoluted, but it really does make sense, as close as I can get it to make sense. So %10 is what I'm going to call this variable that is going to store 10%, 0.10. So this one is not initialized to 0, but it's giving the value I'm going to use in my calculations, which is 10%, 0.10. Do the same thing for the 15% value. I give it a constant data type. I say it's of type double. I give it a name that has no characters in it, no special characters, doesn't start with a digit, and I give it its initial value, and the same thing for the 20%. And then the output. Okay. Again, I have to name these variables. I have to give them a data type. These two are doubles because they can have something to the right of the decimal point. I give them a name, tip 10%, tip 15%, tip 20%, and these are all initialized to 0 so that they're cleared out. These are variables. The amount that's in there will change from time to time, but we need them to be cleared out and initialized before we start the program. So that's it for this demo. I hope it helps. Have a good week.